Over to you, Tim.
Thank you. So what I'm now going to do is I will focus a little bit more on the process itself, of its potential, and how it can be realized with a Koenig Bauer Kammann printing machine. So we call that process digital relief printing, and this is a special developed printing mode which enables you to print such artworks with up to 60 cycles per minute. This is for sure depending on the printing length and height. The layer thickness can vary according to the requirements up to 3 millimeters. And our intense adhesion tests, the results were excellent. So more than 1,000 cycles can be easily achieved with an industrial dishwasher, more than 500 cycles with a household dishwasher. So, and this process provides you, like Tobias already mentioned, a wide range of options. So it's on the one hand suitable for clear relief printing of small and fine details with contour sharpness, as you can see on the left photo, but it's also suitable for clear relief printing of higher and thicker graphic elements, like you can see on the ampersand Koenig Bauer logo. So both is possible. And for those people who are now thinking, okay, that's a little bit plain, that's a little bit boring, even the combination of both, so of the common 4C printing process and the structural relief, the haptic printing, is combinable. And it's important to mention that it can be combined in just one machine. So here are two examples. Some striking visual effects can be achieved. Not too extensive, like in the leaf. There are some fine structures added. On the next page, we have two more examples. Yeah. The excellent Vino di Mara. So combination, in my opinion, this perfectly reflects the strangeness of its process. So we have flat areas, colored areas with the compass, with the landscape, and we have structural haptic effect in the scripture in the Vino di Mara K15. And Fraser, I see your shining eyes. Yeah, it's London Bridge, the Mara gin. Here the same. Fine structures in the bridge itself. And then the combination with structure and haptical effects, contour sharpness. So those two samples, in my opinion, perfectly reflecting the potential of the process. So yeah, let's go on. So it's not just possible to print on cylindrical items. I think in the past it seems sometimes that we just are able to print on cylindrical items like cylindrical drinking glasses, like cylindrical wine bottle, but that's not the case. Digital printing is a non-printing process. So that means to no time we have a direct contact to the article surface. So we don't have a conventional prepress, everything is digital. And those offers two major key benefits. The one benefit already mentioned, and I think that you're all aware of that, is that you're extremely flexible in case of the batch sizes. The other point is that you have the possibility to decorate areas on the article where conventional processes like screen printing, like shrinking, labeling, are reaching their limits. So in the photo in the middle, the glass, I've highlighted some areas with the arrows, just to give you an example. So even complex article geometries and shapes can be decorated with this technology. And this offers, in my opinion, or in our opinion, the next level of design freedom, and hopefully will delight the designers in this industry as well. So, but how is this possible? So how is it possible to print on concave, convex article shapes? This is based on two grounds. So one reason is, got a mechanical reason. We are implementing various axes in our article arm holders to achieve the closest distance between the printhead and the article surface. So, and therefore we have two main axes, which are very important. So on the one hand, we have the tiltable article holders, which are servomotor driven. They can be adjusted individually in each working station, and gives you the possibility of a vertical inclination angle of +20 and -10 degrees. And the other axis, very important, is the Z-axis, also servomotor controlled. So this is based on the mechanical part, and the other important thing is, is based on software. So I've added a photo or a screenshot of this software. So a non-cylindrical article let's say, a complex article. We have a special design software to compensate different diameters automatically. The software is called Kammann CSV Generator. When you have such an article, you have varying diameters, and this leads to varying rotational speeds on the surface. And important for us is to compensate that. So, and in the first step, what we are doing is we are scanning the article. This can be done in two different ways. One, the conventional, let's say, old school way. Do it manually with conventional measuring methods. The other possibility is to do that automatically with integrating an article scanner, a laser into our machines. So this can be also done fully automatic. And then what the software is doing is we can control the individual jetting frequency of each single nozzle. And that's very important. We need to know when we shoot the ink drops that we are in the position to also print such articles. So, and this is possible on rotational symmetric articles like this glass, for example, but also for non-symmetric, non-rotationally symmetric, it's important to mention, articles. So both is possible. Just a shortcut, those are the two main reasons how this is possible. So let's go on. Next slide, yeah. And how is it possible? This is mainly the K15 machine, a carousel machine type out of our product portfolio. And this is how a machine can look like if it's configured to do both. So on the one hand, the conventional 4C digital printing process, and on the other hand, also the possibility to generate haptical effects structures. Okay, let's go to the next slide. Then we start with the pretreatment. When we are talking or when we want to print with UV colors or inks, so we are in the world of digital printing, so it's UV ink, I think, is the correct wording. Then we do have to pre-treat the article before the printing process to achieve an outstanding adhesion. So and therefore we have our machine type K31 in our portfolio. It's a peripheral device. We are flaming on an additive, a pyroxyle or a xylan, onto the article surface to generate an adhesive base. So once the article are pre-treated, we can start with entering into the machine, into the carousel. So this would be, yes, okay, perfect. So once the article are pre-treated, we can enter into the machine. And then we have here a K15 M18 printing machine. In the first station, we have a detection station. Here is an integrated seam embossing camera, which can detect a seam to decide where on the article exactly you want to print, to not print over a seam, just for instance. The next station is a heat control station, very important when we are printing, for example, on glass articles. It prevents that we are getting in contact with the article and cause some damage, for example, on a printing head. And as we all know, glasses do have their tolerances. So that's very important to be 100% sure not damaging anything. The next station is our first digital printing station. There we are applying a jettable primer, followed by an exhaust. Then we are applying printing a pre-varnish, white, yellow, magenta, cyan, and black. So this is our main CMYK process. And additionally, then to be able to generate haptical structural effects, we have added 4 more inkjet stations, which are filled with the high build varnish then. And then we are printing layer over layer to be in the position to print such artworks. And finally, in the end, we have our final curing with a conventional UV bulb, 250 watts per centimeter, to be sure that every layer is totally dry, and then the article is finished.